So today we're going to talk about direct variation. What is direct variation? Well, direct variation is when you have a linear equation whose y-intercept is 0. In other words, you're looking at y equals mx plus b form, where b equals 0. In direct variation, we look at y equals kx. So it compares to y equals mx plus b, where b is 0, and k and m are your slope. K is also called the constant of variation. It looks like this. So your graph passes through the origin. And remember, the origin is the point 0, 0. So we do a couple of things with direct variation. Direct variation is really good with real life problems because a lot of them start at 0, 0. But in general, we want to look at equations. Can we identify direct variation from equations? And it's actually very easy. For the first one, we have y equals x over 2. Is that direct variation? We have a y-intercept of 0, so yes, it is. And our k, our constant of variation, or our slope, is 1/2. So that's how we tell that it's direct variation. For the second one, 2y minus 1 equals x. Is that direct variation? It is not direct variation. Why is it not direct variation? If we change around the equation here, we get y equals x over 2 plus 1/2. This 1/2 gives us a y-intercept that's not 0, so no, this one is not direct variation. The third one, 5/6x equals 1/3 y. That one is direct variation because we have no y-intercept. We have a y-intercept of 0. So we have if you do the math and you multiply both sides of the equation by 3, then you get a constant of variation of 5/2. Okay? So the key to identifying equations of direct variation is to look at something where your y-intercept, your b, equals 0. Make sure it passes through the origin. The next thing that we look at is from a table. How do we identify direct variation from a table? We look for two things. The first thing we look for is we look for our constant of variation. So we're going to find our slope. Remember, slope, constant of variation are pretty much the same thing. So -6 to 3 is a +9. 3 to 12 is also a +9. -2 to 1 is a +3. 1 to 4 is also a +3. Everything's the same. So remember, our slope is change in y over change in x. So it's 3/9, or 1/3. So far everything looks good. The other thing we have to make sure of is that it passes through the origin. So to get our x value to 0, we want to add 6. 6 is 2/3 of 9. 2/3 of 3 is 2, so we're going to add 2, and that gives us the point 0, 0. Because if we add 2 to -2, we get 0. If we add 6 to -6, we get 0. So this one is, yes, direct variation, or k equals 1/3, and then we have our equation of y equals 1/3 x. Okay? The next one is a little bit tricky. So let's do the same thing. If I look at my change in x, -1 to 3 is adding 4. 3 to 6 is adding 3. Let's look at our change in y. -2 to 4 is adding 6. 4 to 7 is adding 3. So that gives us two different k values. We have, for the first pair, we have a k value of 6/4, or 3/2. For the second, we have a k value of 3/3, which is 1. So that doesn't make sense when we have direct variation. our constant of variation stays constant. So our slope is the same no matter where we are on those points. So no, that one is not direct variation. The last thing we want to look at is finding a missing value. So suppose y varies directly with x. If y equals 4 when x equals 3, then find y equals y when x equals 6. Since y equals kx, that's our equation for direct variation, we can use a proportion. K equals y over x, and since k has to be the same no matter which point we're looking at, and remember these are points, so this is the point 3, 4, and this is the point 6, some number, some y value that we don't know. Okay, then we can use the proportion y1 over x of 1 equals y sub 2 over x sub 2. Fill in our blanks from our points, and we get 4 over 3 equals y over 6. And we use our proportion solving techniques and cross multiply. So 4 times 6 is 24 equals 3y. Divide by 3. So we get y equals 8 as our answer. So our second point would be 6, 8. We do the same thing with the second example here. Suppose y varies directly with x. If y equals 10 when x equals negative 3. So remember that's the point, negative 3, 10. Find x when y equals 2, and this is the point x, 2. So again, use our proportion. So 10 over negative 3 equals 2 over x. And when you use your proportion solving techniques, cross multiply, you get negative 6 equals 10x. Divide by 10, and you get x equals negative 3/5. And direct variation is as simple as that. I hope with this you can figure out how to solve some real life examples of direct variation.